So you could use parameter sweeping or something to guess and check your way to this, but we want to be able to actually come up with the equations of the tangent lines. So the key thing to recognize about the tangent line is to remember, we know how to find the equation of the line if we're given the slope and a point. And somebody suggested this in the first week, and we talked about it, but I kind of wish we had done it a little bit more, because point slope form is your best friend when it comes to finding the equation of a line if you know the point and the slope. I mean, it's right there in the name, point slope form. So point slope form is, you can look it up, it's equals slope times x minus x1. And here we're saying that your slope is m and your point is x1, y. Now, we often convert this and do one more step to y equals by adding y1 to both sides. But once you get it set up, it's really not that bad. So I'm going to go back to my question here that asks me to find the tangent line of the curve at x equals -1. And notice that I'm told that the function that I'm working with here is 3x squared. So I'm going to need a point, and the point I can see at x equals -1. I have y equals 3. So that is my point, x1, y1. And I get that just by plugging into the function. The point comes from plugging x equals -1 into f of x equals 3x squared. We add a little. Now the slope, so that's the point, is -1, 3. Now I need the slope. And the key idea here, in fact, the key idea in all of calculus, is that the slope of the curve comes from the derivative evaluated at -1 in this instance. So I can eyeball the slope of the tangent line. See, it's negative. I might be able to even calculate it based on that. But I want a clear symbolic solution. So because my f of x is equal to 3x squared, I can apply power rule and say that my f prime of x, which gives me the slope at any value of x, my f prime of x is equal to 3 times 2x to the 2 minus 1. It's applying power rule and constant multiple rule. So if I simplify that, I get that f prime of x is equal to 6x. And then I want to plug in this -1 into the f prime. So I'm just going to plug in 1 for x, or -1 for x. So I get 6 times -1. And so f prime of -1 is equal to -6. So I had to find the derivative and then plug in the x value I was interested in. I did all of that to get the slope. So now I'm at the place where I can use my algebraic knowledge. But I had to use calculus to get the slope. So now this question has become, find the equation of the line that passes through the point, -1, 3, and has a slope of -6. And this is a question, we did do this question during the first week. So this is a question that, at least in theory, we've seen before. And using point, are there any questions about how we've translated this question to a different question, and a question that we could have done earlier now that we know the slope? Does that make sense? And so now this -1, 3 is my x1, y1, and my m is -6. So I'm going to have y minus 3 is equal to -6 times x minus -3. So y is going to be equal to -6 times x plus 3 plus 3. If I clean this up just a little bit, I'd add 3 to both sides to get y equals by itself. It zeroes out and leaves me with just y. Now, what I love about these tangent line questions is they are self-checking. I have gotten the equation of the tangent line right here. And if I put this tangent line that I have on the curve, I should recognize that it's a tangent line. Right? In theory, I know what a tangent line looks like, and I know that it fits right at that point, -1, 3. So let me add this equation. Y equals -6 times x plus 3 plus 3. Uh-oh, I'm concerned because I don't see the line. What did I do wrong? This answer is not right. This answer is not right because it doesn't look like a tangent line at -1, 3. So what did I do wrong? Look at my work and see if you can find the error. The x1 value, yes. I should have used x1 being -1 here, which would have given me a -1 instead of, and it actually would have given me x plus 1 here. And now I know it's right, because if I look at it, it's right at that point -1, 3, exactly like a tangent line should. So you will know whether or not you found the right equation, because if you graph the tangent line and the curve, you should know what that looks like. And if you're wanting that to be a tangent line, it better look like a tangent line.